Hi students, welcome to the session on causality of LTI system. In this video we see causality of LTI discrete time system, right? So let us see that. I have posted one video on causality of continuous time LTI system. If you see that this is the same concept except t is changed to n, right? The concept is same only. We know that a system is causal if present output y of n depends or function of present input x of n or past inputs, right? Then we can call the system as what do you call causal LTI system, right? So this is causal. Here you see the present output y of n depends on the present input x of n or past inputs x of n minus 1, n minus 2 up to n minus infinity, right? So is the system is non-causal if present output y of n is a function of future input like n plus 1, x of n plus 2 up to x of n plus n, where n tends to infinity, right? So this is non-causal system. This we studied. Now we see the condition of causality of discrete time LTI system. Okay, let us see that. We know the output of any LTI system is given by y of n is equal to summation k goes to minus infinity to plus infinity x of k h of n minus k. That is equal to x of n star h of n, right? As per the commutative property of convolution, x of n star h of n can be written as h of n star x of n. That's equal to summation k goes to minus infinity to plus infinity h of k x of n minus k. This we can write. Okay, this is what output of any LTI system. This summation equation I divide into two parts, where k goes to minus infinity to minus 1 h of k x of n minus k from k goes to 0 to infinity h of k x of n minus k. Okay, now we see that suppose if k is 0, then that means this summation will not have any effect. It will become 0 only because this summation only has value of k is equal to 0. If k is equal to 0, what will happen? Y of n is equal to, it will be x of h of k x of n. That is, y of n is a function of x of n. That is, present output is a function of present input. So it is causal. When k is a positive number, what happens? When k is positive number, for example, k is equal to 1, it will become h of 1 x of n minus 1. Here also you see present output is a function of past input. That is a condition for causality. If for any positive number, it will become h of 2 x of n minus 2, h of 3 x of n minus 3. Present output is a function of what do you call past input. So it is causal. So k0 to k any positive number, that summation will give causality. That's what our aim. So this is talking about causal, right? So what about this one? When k is negative, like this, you see, for any negative number, k varies from minus 1 to minus infinity. For k negative, it will become, for example, k is equal to minus 1, it will become x of n plus 1. So present output is a function of future input, this one, right? So this integration will not come into effect. Similarly, for k n minus 2, it will become x of n plus 2. Minus 3 means x of n plus 3. So for any negative, the system becomes non-causal. What is the topic we are dealing? We are dealing with the causality of what do you call LTI system. For causality, only this summation should come. This summation should be absent. When this will be absent? Only when summation should become 0, and this should be equal to k0 to infinity h of k x of n minus k. When for causal LTI system. When this will become 0? Only when h of k will become 0. it is possible only h of k is equal to 0, because future input may be given, but I want this summation should be 0. This is possible only h of k is 0. H of k is equal to 0 for k less than 0. Yes or no? For any k value, this summation should negative k value, I want this summation to be 0. That is possible only if h of k is equal to 0, because this input cannot be 0. Okay, so this I can write as, for causal LTI discrete time system, h of n, instead of k I substitute n, that is a variable. Instead of k I can substitute any variable for n less than 0. This is the condition for causality of LTI system. That is, then only the integral will become 0, summation will become 0, y of n is purely defining causality. This indicates impulse response h of n should take only positive value of n for LTI D to be causal. Right? So for causal LTI system, D system, y of n is only varies from k0 to infinity, not k varies from minus infinity to original. For any LTI system, y of n is k varies from minus infinity to plus infinity. For causal system, this should be 0, only this should present. So y of n is equal to k varies from 0 to infinity, h of k, x of n minus k. As per use the commutative property, you can write y of n as summation k goes to 0 to infinity, x of k, h of n minus k. For any LTI system, k varies from minus infinity to plus infinity. That's what convolution equation. For causal LTI system, k should go from 0 to infinity. That is, k should take positive value here. Right? These three conclusions are very, very important. I hope you understand this concept. If you have any doubt, please ask me in comment section. Thank you.